Welcome to the Explainer. You know how some mathematicians can just look at a crazy-looking problem and solve it in, like, seconds? Well, today, we're cracking open their secret toolkit and showing you the shortcuts.
So, why work harder when you can work smarter? That's really the core of what we're digging into today. In math, it's not just about grinding out the right answer. It's about finding that beautiful, elegant, and super fast path to get there.
Okay, let's just dive right in. Picture this. You're in an exam, the clock's ticking, and this monster of a problem shows up. Yeah, that little I is the imaginary unit, the square root of -1. Now, your first thought might be, I guess I have to multiply 1 minus I by itself 12 times. But seriously, don't do that. That's a total trap. It would take forever, and you'd probably make a mistake. There is a much smarter.
All right, so our first tool is built for exactly this kind of situation, taming these massive exponents on complex numbers. It's a really slick shortcut called de Moivre's theorem. So what's the magic behind this theorem? Well, it basically lets us skip all of that painful, repetitive multiplication. Instead of taking the long, scenic route, walking around the block 12 times, this gives us a direct flight path, a simple two-step process straight to the answer. Let's see how it actually works.
Okay, this slide just says it all, doesn't it? On the left, you've got the brute force way, just a total tangled mess that would take you ages. And on the right, the smart, elegant shortcut. This is literally the definition of working smarter, not harder. So, how do we actually pull this off? Let's just walk through these steps. First up, we convert our number into what's called polar form. Now, don't let the name scare you. Think of it like this. Instead of giving street directions like go 1 block east, 1 block south, we're giving GPS coordinates, a distance from the center and an angle. Super simple. Once we have that, you can see in steps 2 and 3, we just unleash the theorem. We power up the distance and we multiply the angle. And just like that, the whole thing simplifies down beautifully, leading us right to the answer. And boom, there it is. All that mess we started with, 1 minus I to the power of 12, just collapses into a single, clean number, -64. Now that's the power of a great shortcut. All right, let's switch gears and grab our next tool. This one is designed to tackle another classic mathematical headache, adding up a super long list of numbers that all follow a nice, clean pattern. Just think about doing this by hand. You'd have to figure out all 50 numbers in the sequence, then add them all up. It would be so slow, so tedious, and, one little slip up with your calculator and the whole thing is wrong.
But with the right formula, we don't have to do any of that. We can just jump straight to the answer, which is 3,775. So how on earth did we get there so fast? Let's break it down. The secret weapon here is the arithmetic series formula. And the genius behind this thing is that instead of adding one by one, it's clever. It pairs up the first and last numbers, the second and second to last, and so on, and it realizes they all add up to the same amount. It's a trick that lets us find the grand total in one single, quick calculation. So cool. And the best part, all we need are 3 little pieces of information. Just like you see in step 1, where do we start, how big is each jump, and how many jumps are we taking? You just plug those into the formula, and it does all the heavy lifting for you. It's fantastic. Okay, for our final tool, we're going to tackle a really strict rule in math. You absolutely cannot have imaginary numbers hanging out in the bottom of a fraction, the denominator. It's just not considered simplified. You'll lose points for it on a test. So, how do we clean it up? We use this amazing little thing called the complex conjugate. Seriously, think of it as a mathematical eraser. Its one and only purpose in life is to zap that imaginary I from the denominator and tidy up the fraction. All you do is flip the middle sign and you've got your tool ready to go. So you look at this problem and it just looks messy, right? You've got an imaginary number on the top, an imaginary number on the bottom, but with our new eraser, the conjugate, this whole thing becomes incredibly simple. Let's see it in action. As you see in step 1, first we find the conjugate of the denominator. Simple enough. Then, and this is the key move in step 2, we multiply both the top and the bottom by it. Now watch what happens in step 3. It's like magic. The i's in the denominator completely cancel each other out, leaving us with a nice, clean real number, 25. The problem's basically solved at that point. We just simplify the top and we're done. Okay, so we've just added 3 really powerful tools to your arsenal. Now it's time to think about a new mindset when you approach these kinds of problems.
So here's a quick look back at our new secret toolkit. We've got de Moivre's theorem to tame those huge powers. We've got the series formula to add up long lists in a flash. And we've got the complex conjugate to erase those pesky imaginary denominators. Every single one is a perfect example of how to work smarter, not harder.
And this right here, this is the big takeaway. This is what I really want you to remember. Being good at math isn't just about crunching numbers until you get the right answer. It's about having the insight, the creativity, to find the most elegant and efficient way to solve the puzzle. And that's really the thought I want to leave you with. How many other problems out there that seem totally impossible right now are actually simple once you find the right shortcut? Keep asking that question. Keep looking for those clever tricks. Thanks for watching The Explainer.